Assalamu alaikum. Dear students, today is our first lecture on the course Design of Concrete Structure 2nd CE 701T. This course is floated by the Department of Civil Engineering, Islamic University of Science and Technology at 7th semester. It's a theory course and it has got 4 credits. Moving to the course content. In this course we will study about design and analysis of foundations, retaining walls, water retaining structures, pre-stressed concrete, and finally shell structures. In foundations we will study about various types of RCC footings, design of various types of combined footings like rectangular combined footing, trapezoidal footings, and strap footings. We will also design raft foundations. In retaining walls, we will do the stability analysis of various types of retaining walls. We will learn how to design cantilever retaining walls and counterfort retaining walls. In water retaining structures, we will learn how to design circular water tanks and rectangular water tanks. Coming to the pre-stressed concrete, here we will study general principles of pre-stressing, methods of pre-stressing, pre-tensioning and post-tensioning, various losses in pre-stress, and finally design of rectangular T and I section beams. In shell structures, we will study about membrane analysis of spherical and conical domes by statical methods. We will learn how to design various types of domes and ring beams. This is the list of references suggested for this course. Now we will have introduction of the first topic, that is foundations. A typical structure built on the ground can be divided in two main parts. One part is called as substructure, another part is called as superstructure. Substructure is that part of structure which is located below the ground level, while as superstructure is that part which lies above the ground level. The substructure is also referred to as foundation. So, we can define foundation as that part of structure which lies below the ground level. It is that part of structure which transmits the load of the structure to the soil on which it rests. It's often misunderstood that foundation is provided to support the load of the structure. In fact, it's a media to transmit the load of the structure to the subsoil. Now, coming to the types of foundations. Broadly speaking, there are two main types of foundations. One is shallow foundation and another is deep foundation. Shallow foundation is that foundation which transmits the load to the strata at a shallow depth, while as deep foundation transmits the load at considerable depth below the ground surface. The distinction between a shallow foundation and a deep foundation is generally made according to the Tarzagi's criteria, according to which a foundation is referred to as shallow foundation if it is laid at a depth equal to or less than the width of the foundation. That is, if DF is less or equal to BF, width of the foundation, then that foundation can be called as shallow foundation. And if DF is greater than twice BF, then that foundation will be called as deep foundation. Now, coming to the types of shallow foundations. Shallow foundations are of two main types. One is isolated footing and second is combined footing. Now Deep foundations are also of two types. One is pile foundation and another is well foundation. In this course, we have to deal with the design of shallow foundations only. Now coming to the first type of shallow foundation, that is isolated footing. Isolated footing is also known as spread footing and sometimes as individual footing. When the soil on which the structure is built is reasonably firm, a separate footing is provided for every column. Such a type of footing is known as isolated footing. Isolated footings can be square in plan, they can be rectangular in plan, and sometimes they can be circular in plan. Now coming to the second type of shallow foundations, that is combined footings. In some cases, it may be inconvenient to provide separate isolated footing for columns because of inadequate areas available in the plan, sometimes because of closely spaced columns, or maybe because of heavily loaded columns, or maybe because of low bearing capacity of the soil. All that will result in overlap of areas if isolated footings are provided. This is the resulting overlap. In such a case, it is better to provide a single combined footing for columns instead of providing separate isolated footings for each column. Combined footings can further be divided into following types. We can have rectangular combined footing, trapezoidal combined footing, we can have strap footing, and sometimes we can have raft or mat footing. In this course of design, we have to study about the design and analysis of isolated footings and combined footings. Thank you.